What I'm going to attempt to do is a demonstration of micro-soldering live over Zoom. If it weren't hard enough, the situation is extremely difficult indeed. My microscope has, in the last few weeks, developed a fault in the camera port. So if I touch the camera, the picture will disappear. The camera, it turns out, is not compatible with my video capture card. And the power supply cable to my microscope light is almost severed through and is hanging on by a thread. So the whole thing is a sort of Heath Robinson nightmare waiting to happen. Let's all hope it works. In terms of what I'm going to do, I don't for one moment consider myself in any way to be an expert. There are a lot of people in the forum who do this sort of thing, and I know many of them are much better than me at doing it. The purpose behind this demonstration really is just to prompt a discussion about different techniques for soldering small components, surface mount components. Have a go at demonstrating what works for me, and I've never tried to actually solder something like this under pressure, but pointing out that there are many other techniques than the techniques I'm using. And really, perhaps most importantly of all, is trying to encourage other people to give it a try. And that's on the basis that if I can do it, anyone can do it. Now, sometimes one gets a bit frustrated when people say that sort of thing, if I can do it, when anyone can do it. But I really, really mean it with me, because I am one of the clumsiest individuals going. And what you should see on your screen now is a picture of the base of my angle poise lamp. And if we just zoom in a little closer, you should see the number of times, at least twice, that this has been attacked by my soldering iron. And given that my soldering iron stand is a good 5 or 6 inches away from my angle poise lamp, there's no good reason why I should be melting it. And that really just gives an indication of just how clumsy I am. And of course, I'm well aware of the basic principle of any kind of soldering, which is if it smells like chicken, you're holding it at the wrong end. So the first thing I think I need to go through is what equipment I use. And the first thing is a microscope. Now, this is the microscope I use. I know quite a few other people use it. In fact, Simon, I could see, has something that looks almost identical to this behind him. It's the one that is recommended by Louis Rossman, or Lewis if you want to use his American pronunciation. Now, I know some people are competent at soldering surface mount components without a microscope. I certainly couldn't possibly do that without a microscope. My eyesight just isn't good enough. This is a stereo microscope. It's actually a trinocular microscope, but that's the third port. I don't know whether you can see my mouse, but that port there is just for the camera, and that's really a luxury item, as it were. But you need a stereo microscope. Now, I know some people use video microscopes, which just show on a screen Again, I can't do that because you need the 3D image to get a clear sense of what you're doing. Picking up small things with tweezers under a monocular microscope on a video screen is very difficult indeed because there's no sense of perspective. The second thing I use is a good quality soldering iron and soldering station. One of the issues with micro-soldering is you're trying to get a lot of heat onto a very, very small metal pad. And you need a microscope with a very good, soldering iron with the ability to rapidly deliver heat to pads and to maintain its temperature. This is the soldering iron station I use. It heats up very quickly. It's very stable. It's miles better than the Weller soldering station I had before that, and bizarrely actually cost a little bit less than the Weller station. I think these Hako stations are very good, and they represent a reasonable value for money. The next thing is what soldering iron tip to use, and this is the tip I use for almost all of my micro soldering. It is pretty much the standard chisel tip. It's the tip type that comes with most soldering irons. I do have a number of slightly wacky and unusual designed soldering irons, including ones with very fine pointed tips. But those tips are actually, because they have such a small surface area at the tip, are actually not very good at delivering heat to the pads. And having a chisel type tip is much more effective. And as I'm hoping I'll be able to demonstrate, isn't a problem when soldering onto pads much smaller than the tip itself. The other thing you need is a good quality solder. I know it's becoming increasingly difficult to get hold of, but it is so much easier if you use a lead-based solder. And if anybody tells you that lead fumes come off of solder when you are using it, then that's not so. The fumes are from the rosin and not the lead, and the rosin is the same whether you're using lead-based or otherwise. And the rosin is not particularly good for people with respiratory conditions or generally if you inhale it on a long-term basis. So some kind of fan or fume extractor is probably worthwhile, but lead is only dangerous if you eat it. And I would advise against eating solder if you can possibly avoid it. You can buy very, very cheap solder from eBay, from Chinese vendors. It's a false economy. This is the one I like. Kester Multicore is another one, and there's another brand which has escaped my mind. A roll of this sort of size would probably cost about 25, 30 pounds. I bought my roll about 2 years ago, and I don't think I've got halfway through it. A roll of this weight will last a very, very long time indeed, and it's just a false economy to buy a cheap solder. And the other thing I use is tacky flux. And again, this is the brand of tacky flux I use. Again, it's relatively expensive. This is a 20 ml syringe of it. It's not full when you buy it, so there's probably only about 15 mils in there. Again, I bought my syringe 2 years ago, and I'm about 2/3 of the way through it. So it's a long-term investment. There are all sorts of other fluxes you can use. Different people have different approaches to the use of flux. I like this stuff. I like using lots of it. Again, that's what Louis Rossmann recommends, and hopefully I'll be able to demonstrate why that works for me. So that is my setup. Also, and this is a matter purely of personal choice, I have a fume extractor here. I'm going to try soldering with it on, but I would be grateful if someone could interrupt when I have it on if it is causing a problem with the audio, because it's quite loud. Obviously, I'm using the microphone in my headset, but if it disturbs things, please do say. So I'm going to stop sharing the screen now. What I'm going to be working on is one of these. I'm not going to solder the whole thing. I'm just going to solder a few components so you can see what I'm doing. This is my BeebOPL board, but it's the nano version, which is all surface mount, very small components. This was designed for one purpose and one purpose alone, and that was as a basis to practice soldering. Some of the parts I've used are ridiculously small. No one in their right mind would use those parts on a project like this. It's just, as it were, a challenge to myself. Now, you'll just have to bear with me one moment whilst I change over my feed. And this is going to take a little while because I have to change the audio. And now, of course, immediately I can't find it. Oh, there it is. So I'm going to spotlight this video. And you'll just have to bear with me one moment whilst I make a few other adjustments to get this working. Oh dear, that's gone terribly wrong in a moment. Right, can everyone still hear me? Could somebody just come off mute and just tell me they can hear me okay?
We can still hear you, Robert.
Right, super, okay. So, let's do that. Okay, so can you still hear me okay?
Yep, no problems at all.
Right, so this is the board. The first thing to point out is that the picture I'm seeing is a heck of a lot better than what you're seeing on your screen, most notably the fact that it's all in 3D for me. And what I'm going to start off doing is soldering some capacitors, and the ones I'm going to be soldering are C2, C4, and C5. And so the first challenge is actually to find those ones. So there we got C4 and C5. And so what I do is just put a bit of solder on one of the pads on each capacitor. So hold on, I'm going to wait for my soldering iron to heat up.
Just for your knowledge, Robert, the top of what you're seeing is being cut off for us, so we're not actually seeing C4. Perfect.
Yeah, there we go. Thanks. Perfect. Thank you for that. Do shout if that happens again, because it is a bit of a problem. So there's C4, there's C5, and C2 is somewhere around there. Oh, there it is, C2. Okay, and inevitably, I've got more of a tremor going on than I would normally have, just because of the nerves. And now, in fact, comes what I often find the hardest bit, which is just to pick the bloody capacitors up. So we've got some capacitors. There we go. So what I then tend to do is just melt the solder and just push it in. And I don't know whether that's coming across. Can you see that one?
Yeah, we can see it perfectly. Looks good.
Yeah. I might just zoom in a bit to give you a better view of that. Just check that stays in focus. Now, I don't know whether it comes across on the video, but that, because of the tremor I had, that's a dry joint there. And for reasons that I'll explain, that doesn't actually matter with the technique that I'm using. And for those of you who are familiar with the size of surface mount components, these are 0402. These are measured in thousandths of an inch. So an 0402 is 4/1000ths of an inch that way and 2/1000ths of an inch that way. That's the size. And I'll just do this because it amused Arcadian Dave the other day when I showed it to him. Just for a point of reference, that's a penny. So you can get a sense of the size of what we're doing. And the microscope, in a sense, just works as a sort of sense of reassurance, because it looks so big under the microscope. You sort of believe you can do it, even though the parts are absolutely tiny. There we go. I think that's a dry joint as well. So yes, I've got a much bigger tremor on today than I normally have. So what I then do, and this is why the dry don'ts don't matter at all, is I put a blob of gel on either side of each component. And again, these blobs look absolutely enormous, and certainly Louis Rossmann has a tendency to use large amounts of this gel. But in fact, it's all down to the magnification. This is absolutely tiny in terms of the amount of gel I'm using. Then I go round and just solder the other pad. So here we go with this one. Gently in there and solder the other pad. And just need to give, oops, oh, bugger. Sorry, that's inevitably going to happen. I'll come back to that one and redo it. So here we go. Little blob of solder. A gentle touch on the other side, and because of the flux, it cleans it up, and you get a nice clean solder joint. There we go, and that's the other one done. I won't bore you with trying to redo that other one. It was inevitable that was going to happen with this being a live demonstration. But basically, and it's a heck of a lot easier if you haven't got 40 people watching you doing it on a video link. So the next thing I'm going to have a go at, if I can, is to solder this component here, IC4, which you should see on screen. It's a bit difficult to get it all on. I'll just zoom out a little bit. So that's IC4. And this is a very fine pitched surface mount package. These are 0.5 millimeter pitch, which is pretty challenging. The way I do it, and I think this is a fairly common technique, is to put a blob of solder on 2 of the pins. A bit more there. And inevitably, this is going to be a heck of a lot more difficult when doing it on screen. So there's the component there. I've got to turn it round because pin 1 is in the top right-hand corner on this board. Go. And the trick is just to gently tack that down, and then, whoops, that's not good. You don't want to do that. It's down properly. Okay, it's not the neatest, but it's sufficient. Just tack that down as well. Let's not tack down a bit of solder in there if I can. I think that's tacked down. Right, so that's the difficult part. And then again, almost the same technique as I used with the passive. Lots of solder gel along there, flux gel rather. And then as long as you don't have too much of a tremor, I've got a bit of a bridge going on there. Just go along and do this, and then can usually just do that. So I've now managed to lose my orientation under the microscope. There we go, up there. And again, bit of gel along there. And one really just needs to touch the pins like that. And that looks like that has worked. So again, as you saw, I apart from a bit of a fluff with a couple of bridges which I sorted out, just using an ordinary full-size chisel tip, not much difficulty there. And then finally, the thing I just want to demonstrate, and this is really, I'm pushing my luck a bit, trying to demonstrate this live, but is to solder IC1. And IC1, you can't tell from the footprint, but it's a leadless package. So it's got pads underneath rather than actual leads. That makes it quite a challenge to solder. And I do use hot air for that. I'll show you what I do in a moment. The difficulty with this is that it's got a central pad as well to ground. And it's not a heatsink because this is just an O2 logic chip on here. But it's got this central pad to ground. And the difficulty is that when you're trying to use surface tension to get the chip to align, this pad has an overwhelming effect compared to all the other pads that you're using. On a part this size, we're probably going to be okay. On bigger chips like this, it's a real challenge. And what I tend to do, if possible, is to just put a little bit of solder on each of the pads. Probably got too much on that pad, but it should be okay. So a tiny bit of solder on each pad. And then the trick is to get as little solder as possible on the central pad. And I think there's actually some on there already. Yeah, that's enough. Perhaps a bit more on that one. Yeah. And then let's get the orientation right. So I need to get this out of its strip. So it's extremely difficult to see. There's no silk screen on this part, but pin 1 goes there. That's the pin 1 marker on there. I don't know whether it actually comes across. In fact, it's probably a little bit out of focus for you. So what I tend to do is basically put a blob of gel over the whole area. Whether this is going to work on camera, I do not know. And somewhat unceremoniously pop the chip down and try to line it up as best as I can, and then bring over the hot air. Now I have to, with these size components, one does initially have the problem that they might blow away. Nope, start that again. Right, I don't know whether you saw that, but it sort of just clicked into place. And if I give it a gentle nudge, it springs back. So that's in. And one just needs to let that cool down a bit before you try and work on it. Right, that's okay. Now, what I tend to do at this stage, just as a sort of final sanity check, this is one of the rare occasions when I do bring in a slightly more specialized soldering. This is a micro soldering pencil. I don't think this is absolutely necessary to use this, but oh my God, it's got a cat hair on it. Oh, well. Sorry. It's just to go in there and make sure that this chip, I can't really show it on screen, but the pads end in a sort of, they just sort of show up at the edge of the component, and then you can use that just to run solder along the pads onto the edge of the component. Yeah, that's fine. And there we go. So there it is. Sorry, I've taken that off screen there. What I would then do, I mean, the problem with this tacky flux is it leaves a god-awful sticky mess over just about everything. And so once one has finished soldering, you need to put it in a little bath of isopropyl alcohol to get all of that sticky flux off. And it does get everywhere, so you do need to be cleaning up. Okay, does anybody have any questions or comments? How am I doing for time? So that was pretty much exactly half an hour.
Yeah, you're doing fine for time there, Robert. But there were a few questions before we jump into them. Thank you for that. As I said to you in chat earlier on, I wouldn't do that live, despite having done it for years. I think that was a brave thing to do. You went from a very simple component to quite a simple component to one of the mind-bogglingly difficult components in 3 easy steps. So if I had a hat on, I would take it off to you.
Right. Well, I've got some, just before you go into questions, sure. I've got some bad news for Dave, Arcadian Dave. What I said I would do, because it would just look that much nicer, was to record the feed from my microscope camera natively. And I just turned around to look at the PC that or the MacBook that my camera is connected to, and it says, QuickTime quit unexpectedly. So I'm afraid all we've got there for is the feed from the Zoom video. So sorry about that, Dave.
Sounds like good news to me. It's less editing for me to do. But no, seriously, the video's fine from the microscope. I think it's been really clear over the Zoom feed. So I'm sure what you could have captured's a lot, even much better.
Yeah, and it's not that much better because of, I mean, I've got this really brilliant capture card, which is not actually capturing it. It's going through a sort of intermediate stage, which is ruining the picture image, but it's the only way I can get this slightly sketchy HDMI camera to work. It's all a bit, as I said at the beginning, all a bit weird what I've got set up here, but it worked, which is good enough. So sorry, Simon,
No, actually, one of the questions that I got from 2 places was, in fact, about how you were doing the video capture of the microscope, which I guess is slightly unrelated to it. But
well, I'm happy to answer that question.
Yeah, go for it.
So this is the microscope. This is a microscope camera. It's a pretty good microscope camera. It's got a Sony CMOS imager in there. It's 1080p. It's got an HDMI socket there. And basically that's, in the real world, that HDMI cable would go into my capture card, but this has got a fairly sketchy implementation of HDMI going on in there. My capture card simply doesn't recognize it as HDMI. I'm pretty sure that the people who manufactured this haven't paid a license fee to HDMI, and they're probably not using a validated HDMI processor on board. So it's all a bit weird and sketchy. So what I found was a device that allows you to send HDMI over Ethernet cable to another receiver box. And the transmitter box has a loop back in there. So the HDMI goes into the transmitter box and then it comes back out the loop back out of that transmitter box. And that box is obviously repackaging the HDMI signal in a way that my capture card recognizes. But it's subject to a fairly significant degree of signal degradation going through that box, rather defeating the point of having a really high-end top quality capture card. But basically, I mean, in the ideal world, you just have a camera and you plug it to a capture card. In fact, you can also get cameras that have a USB 3 port on them, and you just plug that into your computer and just capture it, and it just works as a webcam. The other thing is that there's a very delicately assembled set of mirrors inside the microscope head, which split the image to the 2 eyepieces and to the camera. Unfortunately, there's that going on, and that rather defeats all of the delicate engineering in there. That is actually a fault, not with the camera or the attachment, but the top, this bit here, is not fixed internally correctly. So the head is actually going back to the manufacturers next week. I hung on to it for today. I hadn't really noticed it because I'd never really used the camera in Angra before. So it's all a bit Heath Robinson. And the difficulty is if you twist it like that, you're not meant to be able to twist it, but if you twist it like that, you'll see that the image just disappears off the side of the screen. So yes, not an ideal setup at all, but it works.
I think just to add to, I have a very similar model microscope, and I have the USB 3 on top of mine. I think generally People that like to have a big display will have a HDMI, so you can feed it directly into a monitor. But the USB 3 is kind of neat if you don't want to play around with the capture cards. But it's all optional. You don't need that to be able to solder, of course. So
Absolutely.
There was another question from Ian S. He was asking, when you did the hot air reflow work, what temperature was your hot air set to?
350. And I perhaps should just say what model of a hot air station I've got. It's the Quick 861DW. It's another slightly sketchy Chinese brand, but it's a step up the one that you can see knocking around on eBay for something between 50 and 100 quid. So it too comes up to temperature very quickly. It's fairly accurate. It's got a pretty well-controlled stream of air. If you're doing something that requires a lot of hot air, you can turn it up. Obviously, with this kind of work, you actually don't want a particularly strong stream because you're just going to blow the component straight off the board. It says on it ESD, and I've looked at a chat thread about that on the EV blog. No one quite knows what that means, because if your tip of your hot air blower comes into contact with your chip, you've done something very wrong, because that's not what you're meant to be doing with it. I don't know whether there's some way in which, I don't know, you could ionize the air, but that can't be right. I think that's just a bit of nonsense that they just stuck on the front to sell a bit more.
Maybe the handle's grounded.
Yes, I hope it's grounded because it's made of metal, for my own safety.
I think generally with ESD devices, what they say is it's gradients. So it's the more things you have that are ESD protected, the better off you are. So it is more to do with like the handles and all the other things. So the more things you have grounded, the safer your environment is. But it's not like you are ESD safe, you are not ESD safe.
That's the model there that I've got.
So let me just have a look at the other questions. There was another question from Ian S asking if you tried to use the stencil solder paste and hot air or an oven as an alternative to the way that you soldered it.
Yes, I had definitely tried that. I have got an oven, and I've got which I've modified to give it slightly more accuracy. I have had mixed success with hot air, with paste. It's something I want to go back to, but the reality is, for doing a single board, I don't really end up saving that much time. I mean, when you're dealing with, I mean, you know, if you're mad enough to be using components at that kind of pitch, I mean, that quad flat no lead package was a 74 HCT02, and there's absolutely no reason on earth why you need a 7402 package that small. I don't even know why a package that small exists, because if you're making something like a mobile phone, you wouldn't be using discrete logic chips on it. It's an insane package. So there's no real need for it. But if you're going to be using that in paste, you still have to get that pretty well lined up before you put it in the oven, because you can't be 100% guaranteed that the surface tension will effectively position it in the right place when you've got that big ground pad in the middle. And the other thing, I have a MIDI board which I made, and the chip for that only comes in one package, and it's another quad flat no lead package. It's a 48-pin 0.5mm pitch device with a big ground pad in the middle, and it just doesn't work with paste, because it inevitably ends up being aligned a few pins to the left or a few pins up or whatever, because the ground pad just seems to overwhelm all the other pads in terms of surface tension. So for me, it doesn't work. And in any event, you know, having to position all of these things, you might as well have a soldering iron in your hand at the time you're positioning them and get on with it. I mean, I've made about of these boards so that they come in panels like that, and I was at a rate of making, you know, about 8, you know, 2 panels in a couple of hours. That's 8 of these. So I mean, you know, if I was going to be starting to make things in the sort of triple figures, it might make sense. But then if I was making stuff in the triple figures for virtually next to nothing, you can get them all assembled for you in China. So, you know, and plus I enjoy this. This is fun. I just think paste and ovens just feels more like a faff.
Okay, and we have another question from Phil. He's asking, if you're comfortable, could you run through your first few slides of the equipment and items you talked about and just give an idea of how much they cost?
Oh gosh.
See, so we can all tell how rich you are.
Well, most people know what I do for a living, so it's
everything is made of solid gold.
So what do I use? So I don't think you need to know the price of the ankle poise lamp. So I think this thing here, I think it's about between $500 and $600 from either. You can get it from America. It's branded as Amscope. Amscope are a well-known brand, but they don't actually make anything. They just rebadge stuff that's available from China, and you can buy exactly the same microscope from AliExpress for about $100 cheaper. What you won't get, obviously, from AliExpress is the level of customer support. This comes with a 5-year guarantee. When I told them that the camera port was loose, and I've had this for 2 years, they just said, immediately send it back and we'll fix it. There was no hassle with it at all. So I think it's about $500 or $600. And then, of course, you've got to factor in shipping, which isn't too much, but customs and excise. If you buy it through the Amscope eBay store, you can get it through their global shipping program, which means that you know up front what you're paying for customs as well. That's all paid up front. The biggest issue is that you're paying in dollars, and it's not a particularly good time for purchasing things in dollars because the exchange rate is rubbish. But that's the most expensive bit of kit. The soldering iron, soldering station. Now I think you can get, this is a 2-channel station, and I use the 2-channel station just because I can then have the micro soldering pencil and the soldering iron available at the same time. I think this costs about £350. For a long time, it's very difficult to get Hacko stuff in the UK. There is now a proper distributor in the UK, and you can go to hacko.co.uk to get it. Yeah, I think it was about £350, £400, but for a bit less than that, you can get the single channel one. The range below that, it is the sort of old-fashioned traditional one where you have a heating element at the end of the handle, and then you have to screw a tip into contact with the handle. If I just stop the share for a moment and show you, these are the tips that you get for Hacko. Ignore this bit. This is not part of the tip, but this whole thing, it's a I can probably pull it out. There we go. So that's what a Hacko tip looks like. And the connections with it are electrical. So the heating element and the temperature sensor are all embedded in the iron. It's a superb iron. There are other people who make similar irons, and it's worth it, in my view, just going up from the more traditional, simple heating element up to one of these. they're very accurate, they're very fast and responsive, and they make soldering so much easier. And the other thing is that you can buy these tips, and with these insulated sheaths, they're effectively hot swappable, and you can buy a little ceramic pot which you can put the hot one in when you've taken it out without causing serious injury. So, you know, sometimes I've got 3 tips. I've got the chisel tip, I've got this wacky thing here with a little point on the end, and I've got one of these spoon shaped, I don't know whether you can really see that on the camera, but it's got a little spoon in the end of the tip. And it's you can use it for drag soldering, where you've got a little ball of solder and drag it across the pads. And then if I just go back into share, where are we up to in that? And then yeah, that's the tip. And then I don't know. This is, I mean, I think this costs about £25, and I think you pay about £20 for the flux gel. But I mean, seriously, and it is just like, unless you're I know that Chris Morley works his way through a tube every few months, but he's actually trying to make a living out of manufacturing electronic components. But I mean, I foolishly bought 2 tubes, but I suspect my second tube will have gone off before I get round to it. I think technically this tube has gone off, but it still seems to be working okay. And then the hot air station, that's this one here, the quick hot air station. Again, I think that's probably a couple of £100 for that. And we'll just ignore all the stuff up here. Just ignore it. It's not there. It's just a figment of your imagination. Okay.
I think I always get suspicious when I see test and measurement equipment with no probes connected to it. That's someone who's just tidied their desk for the photo.
No, well, no. So we've had new flooring put in, and all of our belongings had to go into storage whilst it was being done. So I've only just unpacked all of my stuff, and these are new shelves. So there's no probes attached to anything, because I've not done anything with any of it. Since I'm still trying to. What you can't see is I'm still surrounded by packing boxes that need to be unpacked and put away.
I think with the soldering irons, one of the things I've noticed over many years of doing soldering is that the better you are at soldering, the cheaper the soldering iron is that you can use. So when people say that, oh, I can do it with a tip that's as wide as my nose, it's generally because they've been soldering their whole life. I mean, I would say that it's worth putting a little bit of money on a Hacko or a Weller or some good quality soldering iron. It gives you a much more consistent heat. Yeah. That means your experience is much more repeatable. And that's what makes it easier, especially if you're learning. If you know what you're doing, you can solder it with a blowtorch. It kind of gets easier over time.
Well, I'd love to see a video of somebody soldering a quad flat no lead with a blowtorch.
Challenge accepted.
Just out of interest, what soldering iron do you have, Simon?
You don't even want to know. I think I told you guys before, I worked for a company selling these things. So I have dual channel high-end Weller stations. Actually, I have 2 of them and 6 soldering irons. I think the total cost of the setup is probably around about £2,500. So, but I didn't pay for any of it.
Soldering station.
Yeah, for the soldering setup.
Yeah, yeah.
But it's quite different what you can do when you're not actually spending your own money. Because I'm not as rich as you, Robert. I'm sorry.
I have to say, I'm impressed that you seem to have a duplex solder dispensing reel.
As I say, when you get free samples from all these companies, it's perfect.
I didn't even know you could have a duplex soldering reel.
It's made by Weller. You just buy 2 of them and then you bolt them together. Actually, I think they still make them. But again, the reason for it is ESD safe. It makes your solder ESD safe, so it's grounded dispensing. So even the actual solder that's coming off the bench is grounded. Because
I don't think there's a grounding point on my. It's just a reel in a box.
So I had one personal question before I let you go, because the other questions have run out. I was just curious, how many times have you soldered your tweezers together?
I've never done that.
Because I've managed to do it like 1,000,000 times.
Now, the problem I get, I don't know whether you can see this, but is that there's a little delay because they've got solder flux on them and they're now sticky. So I have to keep putting them in IPA to wash that off, which is it's just a pain. But that's the flux gets everywhere.
But I think we have 12 minutes. So I mean, we've gone through all the questions now that were in the chat. If anyone wants to ask questions directly on Zoom, please unmute yourself and go for it.
I was going to say, actually, Robert, I use the lower tier Hacko to equally, well, good effect, I would say, and much cheaper magnification.
Well, yes. As I say, it's what works. I mean, I've tried many things and failed, and this setup works for me.
To be honest, I think your setup obviously is much easier, but it is feasible to do it without having to go the whole.
I think. But would you go down as far as 0402s with?
Yeah, I can do 0402s. The problem is you end up having to get your face really close to it, and that's a pain in the neck, and it's not great for your back. I
mean, I have particularly rubbish eyesight, and my glasses are varifocals, and if you're looking at something the wrong way, you can't see it at all.
I would say you don't need a microscope to do SMD soldering, but it sure is a hell of a lot easier if you do. It is immensely easier.
Yeah, I mean, that was the first thing I noticed watching that, because the problem I have with, I mean, I've not attempted micro-soldering. The problem I have with all sorts of things is that, you know, when I was 15, I could see brilliantly well. Now I'm in my 50s, you know, it's, even with a decent pair of glasses, either it's too close and I can't focus, or it's too far away and I can't see the detail. So, you know, some form of magnification is definitely necessary.
The other thing that a microscope allows you to do, particularly a stereo microscope, is that you can focus the eyepieces separately. So you can actually compensate for the variance in the focus of both your eyes, which, trust me, I mean, once you get over 40, you have this. As I noticed, I used to be able to do it without any magnifying glasses or anything. But the other thing is it increases your success rate, actually, because you immediately spot when you make a mistake. And that means you don't go through this whole cycle of turning it on and like, why didn't that work? And then, you know, when you look at it under a microscope, you can see that like there is a microscopic piece of solder and it's just not quite on the end of that leg where you thought it was. So, I mean, I think it's a magnifying glass, sure, if you've got good eyesight, but really if you want to do it seriously, a decent scope, especially an AM scope, they're just beautiful. And they're really useful for a lot of other things as well.
One of the, I don't want to volunteer to do this because it's an enormous pain. But it would be, when we're all allowed to go and do proper face-to-face ABugs again, it would be nice if we could set up certainly a microscope and a soldering iron and some PCBs with some cheap components that no one cared about, so that people could actually have a play around at soldering under a microscope. Because people who are interested, so people who feel, I mean, obviously you've got to feel comfortable with soldering generally, and obviously you don't need to do through-hole components. I mean, I have a magnifier which makes things easier, but you can do that with a naked eye for most things. But in a sense, it's a big investment if you're not sure it's going to work for you, and the opportunity to try it out somewhere before you go ahead it is worthwhile. And an ABug would be an event if somebody wanted to, but it's a huge pain to have to take all of this kit down and reassemble it in an ABug. But if there was sufficient interest, I'm sure we could sort something out.
Yeah, it's a good point, actually. It's basically what Simon said. The better you are at it, the cheaper you can do it. But like you, I'm okay at through-hole soldering, but I'm very clumsy and my eyesight's terrible. So I think if you're using good good kit, it increases your chances of getting it right the first time, instead of what I would probably be doing, which is pushing it round and round forever, trying to get it in the right place, you know.
So I started soldering when I was about 10, and I did that fairly frequently, all through-hole stuff, obviously, until I was about 16 or 17, and then I sort of other things in life, like A-levels, university, jobs, got in the way. And then I didn't start soldering again until I joined ABug in 2015. And for the first couple of years, that again was only through-hole stuff. So I started surface mount soldering, where are we, about 3 years ago, and with the eyes of a middle-aged man wearing varifocals. So there's no way I could have ever become proficient enough to comfortably do that kind of work without the benefit, particularly of a stereo microscope. But if there was interest, it would be nice to set up a demo station at an ABug so that people could see what they were getting into before they actually got into it, as it were.
Yeah, I was just saying to Simon, it wasn't so much about embarrassing you to to cost out your kit. It was just that.
Oh, I wanted to ask the question. Don't you worry.
And it's all online. I mean, you know, it would take you 5 minutes to find out how much these things cost. I mean, the only thing that, as I say, I think, looking at the kit I've got, the expensive hot air station is you know, I was spoiling myself with that. I probably could have stayed with the hot air station I was using before. I didn't particularly like my old sort of traditional Weller, but again, I could have probably got away with it. The reality is that the good quality solder and the good quality flux is a must. I don't think you're not really saving any money by buying cheap stuff. So the only investment that I think was essential for me was the microscope. And technically it didn't cost me anything because it was a Christmas present for my wife, but in reality, that's not how money works in a married couple's house.
And I would say on that, I mean, when you're looking for something like a soldering iron, even if you can't afford a really expensive one, I mean, you know, you can justify it if you're like me and you do soldering every single day. But otherwise, don't buy the cheapest thing you can find on eBay. That's just a waste of time. You need to put a little bit of money in it. Buy something that has a brand like Hakko or Weller or something recognizable with a decent temperature control. So spend a little bit of money. Don't spend huge amounts, but don't go to the false economy side of things.
You don't. Basically, if you can get the soldering iron in B&Q, it's the wrong one.
Yeah. I've just posted the lower range Hakko, which honestly is still a superb iron. It's not the cheapest, but it's solid. It heats up fast and it maintains its heat and can get a lot of heat quite quickly into the tip, and that's really the main thing, as you said earlier.
It's the difference between an enjoyable experience. It's like when what Robert was saying, this type of stuff, it's really good fun. I love doing it. I have so much fun assembling boards. But if you have rubbish equipment, it's not any fun. It just makes you want to throw the board out the window.
So there's something that's come up on YouTube quite frequently recently, and a lot of people seem to be raving about it, is these open source sort of portable soldering irons, the T100, the T80, one of which I think is USB-C powered, and the other, you know, you power it from your bench power supply with a fairly standard sort of DC barrel jack, and it takes it takes Hakko tips or Hakko clone tips in it. And normally and I think they cost between about 50 and £100. Normally one would steer well away from a soldering iron that sort of comes from China and is at that sort of price level. But people do seem to be reporting good results with it. And even I've seen Dave Jones, and let's not get into the whole do we like Dave Jones or not debate. We'd need a separate slot for that. But, you know, he's a professional electronics engineer, whatever you think of him. And he seems to use it from time to time and seems very happy with it. And he does reviews of it. And I've seen, you know, other people. I mean, a lot of the stuff that people do with it is through hole. But it does seem to be, as long as you're putting enough power into it, so it will work, you know, at 9 volts or something, but that's, you know, you're not going to get anywhere with 9 volts in it. But these ones you can take up to about 20 volts if you've got an appropriate power supply. And they seem to be reasonably good. People say, but I've never used one. And
I think with that, we are out of time in this slot. Just to say thank you very much, Robert. It was a great presentation. I'm glad everything worked. I'm amazed it all worked.
Well, apart from dropping one of my capacitors, which could happen on any day, I think I got away with it.
If it had all gone perfect, then we would have thought it was pre-recorded. But it was a great it was a great presentation. Thanks very much. And
Pleasure.
Now we're going to move into miscellaneous chat. So I mean, if there are still some questions for Robert, you're welcome to ask. Otherwise, feel free to chat and ask whatever questions you like for the next 30 minutes, I believe, until AS 1800 when we have a tea break. So I'm in Sweden, so the times are different for me. My clocks are all 1 hour different. But thanks very much, Robert. Anyway, and anyone else wants to chat or has a subject they want to discuss, please go ahead.
Not a question, just to say the same as you. Thanks for that, Robert. And I'd certainly be interested in having a play with someone's kit if they were kind enough to bring it along.
I think I would be happy to bring my microscope along, but just the microscope, because if I start, I don't really want to start taking my soldering iron and all of that. And there are lots of soldering islands at ABug. One of the things I found is a problem. I think we can stop the recording, by the way, whoever's doing that. Simon, I think that's you.
As long as you keep talking about soldering irons, we're going to keep recording you.
No. So one of the things that I have, which has been a problem for me in ABug, is that I have on occasions basically transported the whole of my lab along. And the problem is that when I get, you know, I take a day off work to pack up, but I don't have a day off work, as it were, to unpack. And so what happens is I come back from ABug with everything crammed into a few crates, and then it stays in there for weeks, and it sort of becomes an obstacle for me to get on with whatever projects I'm doing. Because whilst I enjoy doing the projects, I don't particularly enjoy unpacking crates. And so I've become a bit reluctant to take much kit along, just because it sort of becomes disruptive to the things I like doing in my spare time. But actually, the microscope is relatively straightforward to disassemble and transport. I mean, it's heavy, but that's about the only thing to say about it. So if other people were providing a soldering iron, I would probably be prepared to bring my soldering iron along, microscope along, if people were interested.
Jason normally has his scope with him anyway, doesn't he? I could volunteer his.
Yes, well, now there's the question whether he would want to do that. I think see, for Jason, that's piece of kit is part of his professional income, I think. So he may be reluctant to have. I mean, you actually, to be honest, these things are pretty robust. I mean, there's just, you know, unless you come at it with a sledgehammer or something, or decide to do something to the lens, with, you know, under supervision, I can't see that there's much risk of it coming to any harm. It just needs to be packaged carefully, but you know, it's easily done with some bubble wrap.
It's generally flux splashes that you have to watch out for onto the optics to make sure that you keep the microscope high enough off the thing you're doing, because you know what flux is like. It can kind of splatter.
Yeah, I've got myself some new Barlow lenses which increase the working distance, but the problem with that is then the light drops away, because I've got one of these ring lights, and so the light can't be any lower than the bottom of the lens. So I'm wondering whether to go over to gooseneck lighting, but then you get all sorts of shadows and things which are a complete pain. So
I have a Barlow on mine that drops it down to half magnification so that you get a longer focal distance, and I have a ring light sitting on the end of that, and it works really well.
Okay. Well, at the moment I've got a 0.35 one.
Okay.
What am I right at? Which no, I got 0.71. Sorry,
I think it might be worth describing what we're talking about for everybody else, actually, because one of the things with microscopes is that as you increase the magnification, you reduce the focal depth of the microscope. So as you get more and more magnification, you have to be more and more there's like a focal plane that you go into, which makes it very difficult to solder. So generally with soldering, what you do is you reduce the magnification, which then means that you have a much wider depth of field. So as you're soldering, more is in focus as you're working, the top of the component and the bottom of the component. So choosing what type of lens you have on there is it's a bit of a personal thing, but generally soldering microscopes are not super high magnification, and you can generally just change the lenses on them. So I use mine for two things. I use it for soldering when I have it on half magnification, and I use it also for inspecting laser disc surfaces. And when I do that, I go double magnification, and it's you have to bring the microscope all the way down almost on top of the disc to be able to do it. But it's completely different use cases.
So what magnification are you typically using for soldering then?
Half.
Half of what?
That's a good question. Half of what the standard is on an AMScope.
So the AMScope has a range of ×7 to ×45 over its zoom, and I was so when I started off, that was at minimum zoom, which was just 7 times magnification. And then I went, the numbers on the dial don't really mean a great deal, but I suspect I was going at about ×15, something like that. I have, sometimes, particularly if you're trying to inspect your work after the event, when something's not working, I have gone right down to the maximum, but mostly it's, I don't know, ×10, ×15 suffices.
Okay.
The IPA bath, how many times can you use that? Is it just like a one-off and then refill it?
Oh, I don't want to get into the impression that it's something special. It's just a plastic box that I've got that I throw some IPA in, and I that's what I'm talking about. That is the IPA bath. And
but to fill it up.
I don't fill it up. I just put the PCB in the bottom of it and just put enough IPA in, so it's just covering the PCB. And then I've got a lid for it, which I put on, and I don't know. I do reuse it. Yes. Basically, I keep using it until it turns a funny color. It's not really. I'm not trying to. It's
like
not
so many things in life.
I'm not trying to do anything special. I'm just trying to get the boards into a condition where I can work on them without every bit of dust and I mean, you can't work. This PCB now is just covered in gunge, and it's just horrible. If it wasn't working and I tried to put the scope on it, I get gunge all on the scope probes and everything, because that's the problem with Tachyflux. It just gets absolutely everywhere. And it's very sticky.
The reason I was asking about that and about the air gun earlier is most of the videos on surface mount I've seen on YouTube, they were using a heat gun and sort of flowing it and then cleaning it with IPA. Just wondering about how many times you could get away with using the same batch, basically.
You keep using it, so multiple times, and as I say, just enough to come over the surface of the PCB. I mean, that's the great thing with it, because the thing is with these surface mount, low profile, tiny components, you don't need much IPA. I mean, if I had a smaller plastic box to hand, I would use even less IPA. but that's the box that I tend to use.
If you're really swinging on a budget, one of the other ways to do it is just get a bit of kitchen roll, put some IPA on it, and just wipe the board. It works just as well. You could argue about the ESD quality of that, but I mean, IPA is very cheap. I buy it in the big litre bottles, so I mean, there's no real cost sensitivity. But if it's just a quick board, rather than like, you know, if I don't have a little bowl of IPA, I'd just give it a wipe with a bit of kitchen roll. As long as there's some IPA on the kitchen roll, the flux will come straight off.
I've got a few litres of IPA. It wasn't so much a cost thing. It was just a general interest, not having done it before, you know.
Yeah.
But I mean,
what's fairly pointless is what you see people doing on YouTube all the time. It annoys the hell out of me. Is they have a spray gun and they spray IPA all over the circuit board and then scrub it with a brush. And all that happens is that the IPA absorbs the flux. They then spread it around the board with the brush. The IPA then evaporates, leaving the flux behind. So you're just more consistently distributing the sticky over the board. You've got to have something that will absorb the alcohol, the flux away, either by putting it in a bath or as Simon says, using a kitchen towel or some other absorbent thing that will soak up the alcohol once the IPA is on there, but just randomly scrubbing it around the board.
If you want to brush it away, you have to lift up one of the chips and brush the flux under the chip.
Yeah, that's why I thought the bath was a good idea, because you know, the thing about the using kitchen towel, I suppose that magnification, you get all little fibers out of the kitchen roll and
yeah, but it doesn't affect. It doesn't. You know, little fibers of paper do not stop a circuit board from working. Then you can brush the paper away with an ESD brush. So I mean,
if you've got another area to work on and you've got all little fibers all over.
Sure. Yeah, I'm not suggesting that it's the greatest fix ever. I'm just saying if you're worried about using IPA, you can do it with a dab.
You don't need to remove the flux until you're all done anyway. To be honest, you know,
need to remove the flux at all. Yeah.
No, it's not regular flux. I'm talking. It's this tacky gel, because I'm not talking about, you know, when you get the splatters of flux from multi-core rosin-based solder. Removing that flux is a purely cosmetic decision, but with this tacky flux, it just it's all over the board. It'll then, if you're doing a through hole component, you turn the board over, then it gets all over your bench. And if you have cats, basically you have enough fluff on there at the end of the day to rebuild a new cat. It's just gross.
I have got a cat, yeah, and that it was that kind of thing. Like when you drop the capacitor, you had flux all over it, and you're going to have to work on that area again, aren't you? So maybe.
I mean, that's okay.
Is it?
Yeah.
It doesn't really matter.
No,
I mean, I use a thing called a flux pen, which is like just a short pen that has a felt tip that you just squish down, and then you just wipe it across the component, and it puts very little. I mean, it's personal choice how you do it. But the advantage of that is it doesn't make a sticky mess afterwards. You don't even have to clean it off. When I'm doing experimental stuff that I'm never going to show to anyone, I don't bother.
I think a lot of it.
There's no problem with that. It's the tacky flux, which I like the effect of, but you have to clean it off because it makes it just such a miserable experience picking up the board.
A lot of it's personal taste. So I mean, I like using very liquidy flux. You know.
Oh yeah.
And that's just a little needle which you drip it on, and you can get away without cleaning this stuff off. It doesn't make anything sticky. If anything, it makes it powdery. But you know, what works for you. I think this is the point, that you try the things that and you find the thing that actually makes it easy for you to do it and enjoyable for you to do it.
So if you're really serious about your soldering, that's the microscope that you need.
Isn't that the one that Phil had knocking around earlier?
I would be very surprised.
Something like that.
That microscope, I suspect, if certainly if I chose to sell my car, I wouldn't raise enough funds to buy that microscope. It's £9,500 plus VAT for the basic model. That is, I'd love to play with one. So it's got no eyepieces. So you just look in here and you can keep your glasses on and you get a 3D image on this screen here. It's not electronic, it's optical, but you get a 3D image without having to actually put your head up against any eyepieces. Not only, so one of the things with the microscope I've got is if you zoom to the extremes of the zoom, you usually have to refocus it a bit. It won't maintain its focus across the whole range of the zoom. With that, not only will it do that, but it has such a good focal range that you can turn boards around, so you can look at them edgeways, so that you can, because one of the things you often find is if you look down on the board, you can't see little tiny solder bridges, and if you look sideways on, you get to see bridges that you can't always see, particularly if you've got flux there, because the liquid reflects light in the same way that the solder does. So it's quite difficult to distinguish between liquid and solder. This thing, you can just basically turn the thing through 360 degrees and look at it at different angles without having to refocus. So that's the thing. But yeah, £9,500 plus VAT for that.
I think actually, just to add a hint onto that, Robert, one of the things I've noticed when looking for bridges, if you've got the board flat, when you have light shining on it, as you say, it makes it difficult to see certain bridges if they're in certain directions. But quite often you can buy ring lights for the microscope that have 4/4 of the ring light. And what you can do is you can turn it on at the top, turn it on at the bottom, turn it on the side, so you can actually move the light around the thing you're looking at. And sometimes when you do that, it makes it really obvious, something that you couldn't see the other way around. And it's quite a cheap way of doing it. So that's one of the things I tend to do, is flip from side to side with the light, just to see if I can see something different.
All right, that's cool. Yes, I won't have to sell my car then.
Contemplating it just to look at the edge.
The only reason why you buy one of those microscopes is so that you can do like a YouTube video and have one of those microscopes in it. If you're a hobbyist, it's kind of not necessary. It has to be.
The only person I've ever seen actually use one, not the Lynx, it was a different model, but the same brand and the same price, it is Dave Jones on the EEV blog, and simply because they sent him one. I assume somebody's using them somewhere. I would imagine that they're used in high-end professional settings.
It's like when someone asks me, why do you have 5 soldering irons? My real response is to annoy people that only have one.
Yeah, if you go to a proper assembly factory, they'll have piles of those, because if you're doing visual inspection of boards day in, day out, you don't want to be looking down a microscope. Your field of view is too narrow. You end up missing things. So they are sold into big production lines.
But I think the production lines, I mean, I've been to Flear's factory where they have in Sweden, which is not where they make their small cameras. It's where they make their high-end military one-off cameras that they mount on the helicopters. And the setup that the engineers have there for doing soldering is just mind-blowingly nice. But there's no way you can justify or afford that, really, if you're a hobbyist. And again, the better equipment you have, the more enjoyable and the easier things are. So of course it's worthwhile, but you don't need that to do the type of soldering we're talking about, or do the type of thing that Robert was demonstrating. You can do it with you can't do it with crappy kit, but you can do it with fairly basic kit and have a good experience of it. I think that's the key of this whole discussion. Don't be scared to try it. It's really good fun. You'd be amazed what you can do.
That's I mean, I think that's the biggest thing about it, is the one take-home message is, if you're into this sort of thing, it's enormous fun. I have got about 30 of these boards, which I've assembled for no other reason than I just couldn't stop myself. It was just such enormous fun soldering them, and I don't know what I'm going to do with them.
I've got 30 more boards that you can have enormous fun on. I'll send them to you airmail immediately.
But no, it's just fun. It's just fun, and it's I don't know. I find it relieves stress, actually, because it's not. You don't have to think about complicated things. Once you get into the swing of it, And of course, when you're doing, because you do a panel rather than one board, and you'll do all the passives, so you just have all your capacitors, you get fill up all the capacitors first, then all the resistors, and so it just becomes like it's sort of like working on a low pressure production line. I don't know what it is. It's just fun. It's fun, and it's nice when when you have like a leadless package and it just flips into place like it did. It doesn't always do that, actually. I was quite surprised that worked.
You weren't the only one that was surprised, Robert. I was expecting it to go flying across the room.
Yes, it's quite meditative, isn't it? It's you just can lose yourself in something a bit like that.
I think the other thing is that you can do things that other people can't do. There's every time when I show a project like BeebSCSI, the reaction is, I could never build that. It's like, well, that's not true, because I'm an idiot and I managed it. And if I can do it, then pretty much any monkey can do it. It's kind of like, it allows you to just kind of get outside your comfort zone a little bit and work on projects and parts that you otherwise wouldn't have access to. And everything is going SMD. There's only so much you can do now through Hole, and you limit yourself massively by just saying that's all I can do.
I would argue SMD is quicker.
Me too.
Through Hole. I genuinely would, actually. I think
the funny thing is, I used to make my own PCBs before all these Chinese guys popped up doing it, and the biggest time-consuming part of making your own PCBs is drilling the holes. So the reason why I originally went to SMD components is so that I didn't have to drill the damn PCBs. It would take hours. You think it's difficult to solder those little things? Try drilling 190 holes in a 1-inch PCB using a drill in your garage. Like, after a while, you'd completely boss-eyed. And before I started doing it, I always thought, no, that's too difficult. And then I tried it, and it was like, oh, well, actually, this was a lot easier than I thought. I mean, you don't need a really tiny soldering iron. No. You just need one. Generally, the rule is with a chisel tip that you want the tip to be about as wide as the pad that you're soldering onto. But that doesn't need to be the case. You don't want it too thin, because then you don't get the heat transference that Robert was talking about. So it's okay to have it. I usually use a tip that's about as wide as the kind of biggest SMD component I'm using, and then I just use that tip across the board. For really fine pitch things, I have another soldering iron that has a much finer tip. But with that one, because the heat transference is so much more difficult to do, it cools down as soon as you touch the PCB, because the tip is so fine. It actually makes things a little bit more difficult for most things. So it's a fallacy that you need a really fine soldering iron and lots of a kit. You don't. You just need practice.
Practice and tweezers.
That as well. But if Daniel can do it, and I can do it, and Robert can do it, anyone can do it.
So what Simon said about SMD components is also, if you can imagine a thing that a gadget can do, there's probably a bespoke chip, as it were, that does that, but it will be in a surface mount package. One of the things that I've discovered, and quite a few people have discovered, is this wavetable MIDI synthesizer chip that's got all of the general MIDI instruments stored on it, and it takes MIDI instructions and outputs audio, and it's got all of the audio stages. It's got the preamp and built into it, so it squirts out line level audio at one end, and the input side is 8-bit parallel. So it's like a gift for anybody who wants to do music on an 8-bit machine.
Can you just do a wavetable ad lib on that thing then?
Well, no, it's not. So you can do it. You can. It's got samples. It's a sample thing. It's much better than the ad lib sounds.
No, that's what I mean though. But you could run off an ad lib clone that had sampled sounds rather than.
Well, you're talking about things like the ad lib 3.
Well, I'm just thinking the ad lib was OPL2, wasn't it?
Yes, but the board itself just had the OPL2 chip. You couldn't, as it were, play samples on it.
No.
But what this is a chip that has got actual instrument sampled. So you give it MIDI commands like play middle C on the honky tonk piano for half a quaver or whatever. But the input to the chip is an 8-bit parallel bus. So it's sort of like if somebody was designing it for the kind of things we play around with, but it's in a surface mount package. It just comes in the one surface mount package. And I put it on a little board, but I never really, I wrote some very crude software that sort of got it starting, and it works fine. And you know, but there's an almost infinite array of things like that out there. And I know people have taken that chip and made various other boards. There's an Arduino board with that chip on. There's a board that goes in the parallel port of a PC and has a TSR program that basically allows it to work with any game that supported things like whatever it was, the MPU, whatever. But you know, you've got to get your head, and that unfortunately is it's one of the trickiest things I've ever soldered, because it's this 48-pin quad flat no lead thing with a big ground pad in the middle. So it is absolute bitch to solder. I've actually done some small BGA devices which were easier than that. Sorry, what was that, Dan?
What's the chip called?
The SAM 2695.
SAM 2695.
If it's difficult to solder, you just buy 5 of them and keep going. You lose a few across the room, but eventually one goes down. So it's fine.
Somewhere I can't find that little board that I showed you, the OPL board. I've got about 10 more boards that are basically the same footprint and have the same decoding logic on, but then interface with that chip. So, but I seem to have lost all of them. I've just lost my box of boards. Just bear with me one moment.
While Robert finds that, maybe you might be interested in this if you can see it. It's a 15 gig transceiver for cellular network.
Oh gosh, slightly out of focus.
Yeah, that better.
Yeah.
Yeah, the PCB is my design, complete my design, the electronics and everything, but the nothing to do with the microwave stuff, and that's at 15 gig. We went up to 95 eventually, so we were using 0201s and 0105s.
Are they so dust?
Yeah. Yeah, we had a girl who could rework them.
Seriously?
Yeah, and that was a very expensive microscope.
So I'm just going to bring up my microscope feed again, and let's zoom right out and see if we can get this in some kind of better focus.
That's good.
So that's about as good as you get on this board, but that's so I can't show you any more of this board because that's as far as the microscope zooms out, but that's the chip there. So yeah. It's by far from the easiest thing in the world to solder, but there's very little else on the board. So there's some logic decoding at the top, and then you just got some decoupling, well, not actually coupling capacitors on the audio output, and then it comes straight out stereo audio.
Quite neat.
And so basically, I've got a micro USB that gives a 5-volt supply, and this is a 5-volt chip. I mean, you know, it's amazing. It's a 5-volt chip with an 8-bit parallel input. It's clearly got retro computing in mind, and you know, some Jelly Bean logic, and a stereo output there, and it sounds amazing. It really, it's a wonderful little thing, but I just sort of lost the enthusiasm about writing the code, which wouldn't be that difficult. But basically, you know, I got something that would sort of play, download a MIDI file from somewhere, it would sort of play that MIDI file. But let me unshare that so that, and that's not what I want to do. End spotlight, cancel spotlight. We're still recording, by the way.
Yes, because we're still talking about the same subject, but I've been told that it is now time for us to wrap this up and move onto the tea break, or everyone is going to die of a very British style of thirst. But again, Robert, thanks very much. It was a great presentation.
Pleasure.